Hello everyone. Let's start with today's topic, OOPS, in which we are covering point to point. First of all, we will take basics. After that, we will talk about interview questions along with the code explanation. At the end, you will get notes and code link in the description. So, topic we are covering with access modifier, static and dynamic allocation, constructor, four pillar, and some interview question along with it. So, let's start. So, first of all, what is OOPS? If you think video is too slow, just speed up 1.2x. So what is OOPS? OOPS stand for Object Oriented Programming. So OOPS stand for Object Oriented Programming. You can think in a term of real world project like real world object, just like hospital. Hospital. In hospital we have doctors and patients. Similarly, in terms of programming, we have class, and in class we have member and its member function. Okay, so this is OOPS. So let's talk about first of all what is structure of OOPS. So the structure of OOPS something look like this is our header file for in C++. C++. We generally denote OOPS classes. So here is our member, its member function, member and member function. After that we have our int main, in which we create object of the class, object of that class. So let's talk about first thing, what is size of an empty class. Empty class. So suppose I describe an empty class. Let's see one example. So here one empty class. This is an empty class. Empty class. Let's let's this is an empty class. So what do you think, what is the size of this class? Just pause the video and think about this. So let's run this code. The output is 1. So the size of this empty class, the size of this empty class is equal to 1. Why 1? Because this is to keep track of the empty class. Why the size? So what we see, size of empty class is 1. Why it is 1? To keep track of that class, of that class. So let's talk about next topic. What is access modifier in class? So what is access modifier? So access modifier are kind of three types. First is public, another one is private, and protected. So if you define any member, if you want to access this member, suppose I define a class in which I have described a variable that says x. Okay, so if I want to access this variable, how can I access? We can access usually in three more: public, private, and protected. So what does this means that in, let's talk about first public. So in public, let's suppose, take this example. This is a variable x. If I want to access this variable, I can make an object to this class. Suppose I have a int main function and we created a object of this class object. Okay. If I want to access this variable, I can directly access object dot x and put this value, let's suppose 7, anything. So it can be accessible in the object form which we create in our main class or any other function. Okay, so let's talk about second is private. So let's take the similar example. Uh, Here it is one object dot x is equal to 7. So in, if we describe it private, let's suppose private is here the keyword. After that we will also show an example. So what do you think, whether it is accessible or not? So it is not accessible in main function or any other function if we describe. So what is the role of this, basically private? So private help us to describe some logic, some logic behind the variable. So what we gonna say, just suppose, let me take an new slide. Suppose I have a person. Let's suppose I have a class named person. So if the person is 18 plus, so I have to check it's a 18 plus person class. Okay, so int main to access private member, to access ACCESS, because we can't access in this way. Object, we create an object dot x is equal to 7. We can't create in this way. So let's talk about how to access first. So basically for accessing we need a getter slash setter function, setter function for that variable, for that variable. So what is getter and setter function? Let's see. Suppose here it is a person class and a variable described as int x. Okay, so if I want to access this x uh, outside this class, so what I gonna do? First of all, in public, which I can access the member beyond, matlab, outside the class. So basically, let's suppose I have created a function which is a void type. Let me erase it, which is a void type, and I want to set this value of this. So what we set underscore x. So here we get to know what we are setting. So let's say, let me rub this. So yeah, so what we are setting here? So basically we are setting the value of x in which we have to pass a variable x value. So int, let's, yeah, so here if this is a 18 plus person class, suppose this variable is age. Okay, so what we gonna do, we check first if this x value is above 18 or not. If it is 18, then we gonna set the value of x is equal to x value. Here it is underscore x value. Otherwise, we gonna discard it. We gonna discard L, not else. Okay, otherwise we're gonna discard this value. So because we have to take care of 18 plus, so if the value I passes in the main function, let's suppose it's main function, I created an object of that person. Okay, so if I want to object dot uh, what I have created, set value, set x. So if I passes 9, so first of all it gonna check whether it's x value, whether 9 it is greater than 18. If it is not, then it does not gonna set this value. Okay, otherwise if it is 19, suppose yes, it's this condition is true, after that the x value, what is this age factor, it's gonna set with the x value. Okay, so either if it is 19, so after this condition our x will be become 19. So this is the function of a private. So let's see another protected member. So this is a private member. Private member, in when we go talking about four pillars, we get to know about inheritance, something called inheritance. Don't take care about this right now. I'm just explaining for the third parameter, which is protected. So when we create a class A, suppose we create a class A, something, okay. After that, we inherit this class in a public mode. Does just see what I am doing. Don't take care about what is inheritance, how it is inheriting, what is the function. So in if we define a variable called protected, it gonna access in this class also. Okay, so let's see one example. This is a copy of all the examples. If you wanna, I will provide you in the description. So let's see. Let me delete this. One thing. Yeah. First of all, we gonna see what is access modifiers. So here we have described publicly. So in health, which is basically if we write a function here, int main. So let me, if we describe a function, it will be accessible in that function. Okay. So it is simple. Let me take another example. Yeah, here it is. So yeah. So first of all, let's see what is public, what is private in this example. Let me set my cursor little bit smaller. Yeah, it is fine. So first of all, we describe the variable, which is a private. So our A, let's suppose A is equal to private. Okay. Then we describe a public variable, which is a B. B is public. Okay. So after that, in public class, we describe a variable which is getter, as you can see. So we have a function called getter, Getter, which is also a public. Let me delete this. Yeah. So after that, we created a protected variable, which is C, which is equal to 3. Okay. Its value 1, its value 2, its value 3. This is protected. So what is the value? Its value is 3. So let's how to access this variable. So first of all, yeah, let me rub this. So yeah, in main function we created a object of this class. What is this class? We have a class name function, and we have a inheritance class which is inheriting this function for to see the whether protected is working or not. Okay, so let's start again. So in a main function we created an object of the function, and for the function one, which is this class inheriting class of the of function fun. So we created a two object and object 2. So first of all, for accessing public member, we created a generally, because in public member we can directly access. We can directly access directly access. Okay, in main function. In main function, after creating after creating object after creating object of that function class. Okay, so that's all. After that we will take care of. So after that we will call the object to print class. What is print class? It will print our protected member, which is C. Okay, so it will print my C where object dot getter. So why getter? Let's suppose we have to print directly. Let me change my cursor. First of all, rub this also. So yeah, let's talk about. I have to print this private member. Let's print private. Okay, so object dot a. So will it work for me or not? Let's try this. So yeah, let's try to run this. So yeah, it's showing me error. It gets me error. Function a is a private within the context. Okay, so I am accessing in a wrong way. So let's comment this line. So for accessing my private member, we need a getter function, getter slash to set. We need a setter function. Okay, setter function. So let's run it again after commenting this line. So let's run. Yeah, so as you can see, we are getting the classes. So private member 1, protected member 3, private member 1, protected member 3, and public member 2, as we got our answer. So this is how we can access public, private, and protected member. Okay, so I show one example along with it. So how we can use what we call private member to set behind a logic of that, so no one can accidentally change the value or put the value which is incorrect. Okay, so let's talk about next topic. What is our next topic? Next topic is we have size. So again we will talk about what is size. This is an important topic. So let's see size of a class. Previously we see basically size of empty class which is equal to 1. Okay, so now we will see what is the size of the class. So suppose let's see again one example. So let's copy one example from here. This is my repository, you can use for the reference also. So yeah, let me change it and delete all the variables. Control V. Yeah. So let's first of all create a assumption. Yeah. So first of all, let's create a rough estimation what this what is the size of this class. So first of all, we will take care of character. So character usually have the size of one integer. There are two integer which are public protected. It doesn't matter. Okay. So it doesn't matter. So first of all, what is the size of an int? So it will be 4, and again it will be for this integer. For C it will be again 4. So 4 plus 4 plus 1. So what it will be? 4 4 1. It will be 9. Okay, it will be 9. Let's print the size of this class object. Okay, so let's print it and see what it gonna return me. So it is returning me 12. So I am getting out 12. Why? Why? I am assigning the sign of 9 bytes, 9 bytes, and I am getting 12. Why? So basically the logic behind is if you're thinking that this variable takes more size, let's also print the size of that variable. Let me print it. So yeah, let me check whether the I am taking a correct size. For integer I am taking 4. For uh, here I have done a mistake little bit. Here I have to print character char. Okay, let's rerun it. Yeah, so for character we are using 1, for integer we are using 4. So I am doing a correct way to calculate the size, but my size in the class is getting wrong. So why it is so? So basically there is a concept called uh, greedy alignment, greedy alignment, alignment and padding. So for I'm not going into details. Basically padding means it will reserve the size of 4 plus 4 plus 4, which is answering me into 12. Basically, suppose I have a 4 byte here. So for character, which is actually of 1 byte, it reserving 4 byte. It preserving 4 byte for any future access. Okay, this is mean by padding. It's actually gonna pad up uh, in a power of 2 basically. So 2 raised to power 2, 4. So for that, it's using a padding. So what we can say like uh, basically for future reference, it will access this 4 byte in future. So this is called padding or greedy alignment. I'm not going into depth. You can search on Google. So this is why we are getting 12 sites, not 9. Okay. So let's move on the next topic. Yeah. So next topic is this is our size. We see a concept of padding and greedy alignment, greedy alignment. Okay, we see here an example, which is a we describe two variable a, b, c and a character c. So here it is a size of 4 plus 4 plus 1, which is 9, and I am getting in code I am getting answer my 12. So yeah, that's all about the size of a class. So for padding and grid element, you can reference the Google document and research paper. So let's move on the next topic, which is our static and dynamic allocation of a class of an object. So let's see. Static slash dynamic. Yeah. So static plus dynamic allocation of object. So first of all, for dynamic, let me write form for dynamic. We use what we keyword called new in C++. In C++. Okay. In C, we usually, when we're allocating dynamically, we use malloc and calloc in C. Okay. When we are allocating it dynamically in C. So we use malloc and calloc in C++. For dynamic allocation, we use new. It is a keyword. Okay. So let's see what example. Let's try to understand it with example. Let me here. So yeah. So let's talk about this example. So this is dynamic allocation of the class. So first of all, we make a class here named hero. So examples which I take from YouTube, some good YouTuber like Love Bubba, and some of examples are mine also. So take care of that. Okay. So let's talk about an example where we have a class named hero. Okay, in which we have a private member health. Okay, this is a private member. Let me write it. Uh, Health is our private member. Private member. Okay. Level is my public. Since health is my private member, we need a function called getter and setter to set this value and to get this value basically. Okay. So here we describe the two function, set health and get health. So why I'm defining when I am accessing publicly? So basically to take care of that uh, for any unnecessary changes, I am because it is a good practice. Okay, so I am accessing our health function by setting health and getting health. Okay, which we gonna return me health, and for void which gonna set my health h. Okay, so this is the now we will talk about some. This is the basically my class. So let's talk about what is the main function is doing. So in main function, how is we basically statically align a class? We create a object, object A. This is my object. So for setting my health, I'm using A dot set health. For setting my level, I'm setting A dot set level. Okay. So here you can see, let me rub this first. Okay. So here you can see for set health, for set level, I am using this function inside my class. Okay. So after that, this is the static allocation. Static allocation. Okay. This is my static allocation. For dynamic allocation, I uses a new keyword. This is the keyword. Here I describe my object. This is my object. This is my object, and we are using pointer for describing it dynamically. Okay. So for accessing, now we use arrow function. Okay. we use arrow function to access, or we can use dereferencing the pointer similarly like this way, star b dot set health 80. Okay, this the function which is this is same basically. So let's try to print the output. So yeah, let me delete this. Let's try to run this. So this is how basically we dynamically allocate our object inside C++. We use new member, we use pointer here. For accessing, we use arrow function here. Okay, so this is how we can allocate dynamically an object. So you can see here. So let me write also here. For dynamic allocation, we use, suppose we have a class name, we have a class, we have a name, and let's create an object pointer. Let me up this. This is my object. For new, we create a class name which is my class name. Okay, so this is how we can dynamically allocate an object. Okay, so this is how static and dynamic allocation of the object done. Now we will talk about constructor. So let's talk about constructor. So let's see what is constructor is. Constructor is basically when you what we gonna say, let's when you make an object, a default constructor is called. So this is basically behind the working of that class. This is basically behind working. Let's suppose we create a class name, let's suppose hero. We created a class, and in int main we created object of this class object. So what is, while we creating object, a default constructor is called which describe this class. Okay, which describe this object. Okay, so what is it's doing, it's called object dot hero. A default constructor is called. Okay, behind the scene. So this is the working of constructor. So some properties which we're gonna see, it's creation object creation invoke. Second is it does not have any return type. It does not any no return, no return. So it does not have any return type. Okay. Third is no input, no input type. Okay. No input type. We don't take any input in the constructor. Okay. So let's see some of the basic constructor with examples. Okay. So let's take a example. Uh, yeah. So here is my constructor example. So we see some of the constructor. Control V. Yeah. Let's explain one by one what is this code is about. So let's see from top. We define a class hero. Hero is my class. Okay. In which we have described a variable called health, which is private. Again, health is my private, and we have a two public function, public member, public first is level, and another one is name array. Okay, so let's see how this work. So we create a constructor. This is a constructor how we basically made. Okay, this is my constructor. So how we can describe? We describe as the class name and a function along with what is a constructor called, or what we gonna say, a defining object. Okay, object invoke done. Okay, so after that we will see some constructor which is parameterized constructor in which we pass some parameters. Suppose we are passing health, so it will invoke my object along with setting my health. Okay, setting my health. So this is parameterized constructor. So this is what we call a copy constructor. Let me see. Yeah, so this is a copy constructor. We will talk about brief what is copy constructor. We have a shallow and deep copy. What does it means? How does it works? We see later. We see after this. Okay. So let's try to. These are some getter and setter function to set the health, to set the level, to set the name. Okay. So let's see. Yeah. So let's run this code and see what is the output. So yeah, when we create an object, so check line by line. So first of all, we create an object. This is an object. We create an object. So after creating an object, first we have a object creation invoke has done. So let's see here. Yeah. So when we create an object, this function will invoke automatically. Okay. This function will invoke automatically. So this is a my custom constructor, and if I don't write this, it will automatically call the with default constructor. Okay, it will automatically call my default constructor. And one thing is important here, when I create my own custom, when I create this, when I create this custom constructor, okay, my default constructor automatically what we can say destroyed. Okay, my default constructor automatically get destroyed. It does not work anymore. Okay, after we create a custom comparator. Okay, custom constructor. Okay, so it's a kind of tongue twister little bit. So if we make a on constructor, default constructor got deleted and not been called. Okay, so let's write in note. Let me put this uh, 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 constructor. Yeah, here we're gonna write this. So what is the important point? If we make if we make on constructor, okay, if we make on constructor, the default constructor automatically got deleted, got deleted, deleted, and not been called, not been called. Let me rub this, not been called. Okay, so this is the important point in which we have to keep in mind whenever we create our own custom constructor with our default constructor got deleted. Okay, default constructor got deleted and not been called. Same with parameterized constructor. Okay, so what we let's talk about something. Uh, we describe our parameterized constructor. We see an example. So what is parameterized constructor is basically we create we invoke a class object by passing a variable anything which we gonna do. So basically in a custom constructor, what how this gonna work? We create a object. Let me change my color. So this is hero. This is my class. So this is my parameterized constructor. So this is gonna health is equal to set my health. Okay. Whenever I invoke my object. Okay. Whenever I create my object. So basically, here health is my what we called int health is my private member. Private member. Okay. Health is my private member. So what this gonna do? It will make a class. Let's suppose we have a health over set to 3. So this is our health. So whenever we invoke a class, it will redirect to my uh, object variable, which is basically 3. To handle this, to handle this, we uses a keyword called this keyword. This keyword. Let me change the color of this. Uh, yeah, this. This is also my keyword, just like new for dynamic allocation. For dynamic allocation, okay. For dynamically allocation, we use new. For accessing the class member, we use this. This is basically my what we gonna say current object, current object address. This is our current object address. Okay. So this will store. Suppose I have a function called Ramesh. I have a object called Ramesh, which is at address 7110 710. So what this keyword do, it will store my address basically. It will store my 710 address. So this is basically, let me little bit take up. Yeah. So this is basically pointer pointing to my current object. Okay. Let me, it will pointing to my CURRENT current object. Okay. So this is how a parameterized constructor work. So let's see another example of copy constructor. Let's talk about our third copy constructor. Okay, copy constructor. In copy constructor, we have two constructor. Basically, we create a copy like shallow. What does it mean? I will show you in a bit. Shallow and deep copy. Deep copy. So what does shallow copy means? Okay, let's see. what does shallow copy mean? So we have a object called obj1. So it is having a two variable. This is our integer and this is our array. So this array is gonna pointing to the some memory address. Let's suppose 7110. Okay, 710. This is our array. This is our object one. When we create a shallow copy of object one is equal to object two. Okay, so shallow copy in shallow copy, basically what does it take? It's created a integer same as this. It will copy our integer value to this object 2. Okay, uh, object 2, and it will array for array it will pointing to the same location as my previous object 1 is locating. So if what shallow copy do is basically let me rewrite it. what sh uh, what shallow copy do, if I change anything, if I change anything in object 1, it also gonna reflect me in object 2. So this is how shallow copy works. Okay, so this is how shallow copy works. When we pass the object by address, it cop custom copy constructor, otherwise we stuck in a loop. Okay, this is a main point. So this is how shallow copy works. Now we will talk about deep copy. So how deep copy works, let me write it. Deep copy, deep copy. So what is deep copy? So in deep copy, this is the same function. Let's create an object 1. We have integer, we have an array which is pointing towards address 7110. When we creating a deep copy, it resulting me the same object 2. We have an integer, we have an array. Now in deep copy, the difference is basically when we create a deep copy of object 1, object 2 is a deep copy of 1. Let me write deep copy of object 1, object 1. Okay, when we create a deep copy of object 1, so it will point me an array to a new location, suppose 810. Okay, so whenever I am changing anything in object 1, when I am changing something, it does not gonna reflect me in object 2, which is a deep copy of 1. So this is how deep copy works. Okay, so let's see an example. So let's delete this. Yeah, so let's see one example how shallow and deep copy works. Let me copy this. And what is the difference in the code? Let's see. So yeah, so this is the code of shallow copy and deep copy. What does it means? So first of all, we will check what shallow copy does. As we see in example, let's me comment this part so that we can shallow copy. Yeah, so let's run this. So shallow copy does not run in this compiler. Basically it does not allow two block, basically it does not allow one block. So let me compile in some other block. Let me show. uh, this, let me write it here. What is the output when we run this object? So basically the output of this object, let me show. let me show, let me write this. So here is, let me just wait for a couple of seconds. Yeah, so let me write this code here. Control A, copy, Control V. Let me save this. So let me save it. Shallow.c++. Okay, so let's try to run this code. Stuck ho ja. Yeah, so let's try to run this code. So yeah, as we can see here, let me just 1 minute. Yeah, so what is the output? When we create an object, we create a shallow copy. This is right now it is shallow copy. Okay, so when we create a shallow copy, it will, when we change our object, let's suppose I am changing my object to, okay, just wait. So as you can see here, we create a shallow copy. After creating a shallow copy of object 1, we changes our value to 20. So if I am printing object 1 first, object 1 value of x and object 2 value at x, so it will printing me same because I didn't change any object value in 1. Okay, so this is how shallow copy works, because it share me the same memory along with the deep copy. Okay, so let's comment this and let's uncomment this. So in deep copy we share a different copy. Okay, so let's run this. So as you can see, after changing object to variable x, I am getting my original value of object 1, which is which is actually IPASS's 10. So this is how deep copy and shallow copy works. So yeah, that's all. So let's talk about another topic, which is our static keyword. What is static keyword means and how does it works? So let me do something. Yeah. So first, what is static keyword? Static keyword. So what does it means? So static keyword is basically we can access this without creating an object. Okay. So um, what basically when we create a class, let me change the color of my pen. Yeah. When we create a class and we create a member, so to access this member, we have to create an object. Okay. While in static keyword, we does not create any object. We can directly access this member inside our main function. Okay. Let me just a minute. Let me move this a little bit. Yeah. So here, whenever we creating a member, we have to create an object to access this member. Okay. So while in static keyword, we can directly access this member in our main function. Main function. Okay. It's simple. So how this is initialized, first of all, how this initialization work, we will see. We have a data type. We have a data type. Along with this, we have a class name. We have a class name. We have a, this is what we call scope resolution operator. Scope resolution operator. Okay, this is our scope resolution of operator. and we have a field name is equal to what value we are assigning to this static keyword member. So there are some properties. This is how we initialize it. Let me write it. Initialize. Okay. This is how we initialize a static keyword. Uh, we gonna see one example. So how? Let me show some properties of it. So what are the properties? So first property is object create keyword. Matlab, what does it means? Basically, we does not have to create an object as we see it is a static. Okay, this so in this we does not have object, we does not have this. This is keyword which we see above. It does not have also this keyword. So basically this is basically pointer to current object. Current object. Okay, simple. This is, and it can be only access static member. Only accessing static member. Okay, simple. These are the three which we have to keep in mind while using a static. So let me see. I have an example for this or not. Yeah, I have an example. So let me copy this. Uh, uh, yeah. So yeah, as you can see here, we created a class. Let me remove this. We created a class. We have a health. It's basic because I have used the sim function for the sim for many of the codes. So here I have declared static keyword, static in time to complete. Static in is static function which will return me time to complete. Here I am accessing this time to complete member without creating any object of this class. Okay, okay, this is how it's work. So I am not creating, I have not created any object. I have not uses any this keyword to access this time to complete. Okay, so inside my main function, let me, yeah, inside my main function, I have called this time to complete and time to complete function. Let's run this code and see the output. So yeah, we are getting 5 5. Both the answer is correct. So you can see here, we does not created any. This is how we can, I show the initialization, hero time to complete, hero time to complete. This is how initialization I have shown above in notes. Okay, so this is the same. We does not create any object, we does not create any, we does not use any this keyword object and this keyword. This both use both this both we don't doesn't use, and although we are accessing time to complete without any object this. Okay, so let's move on the second topic. So yeah, so our setting topic is, next topic is four pillars. We talk about four pillars. So let's talk about four pillars of OOPS. So what are the four pillars of OOPS we generally talk about? So first, two, three, four. So first pillar is, it does not uh, it does not have any order. Encapsulation, abstraction, ABS, traction, abstraction, inheritance, and another one is polymorphism. Polymorphism. Okay, these are the four pillars of OOPS. So let's talk about this. Yeah, first we will talk about encapsulation. Encapsulation. Okay, so what does it means? Encapsulation means you can think like of we have a capsule. Let me do this. Yeah, we will think about basically it is used for information hiding and data hiding. Information hiding and we have data hiding. We have data hiding. Okay, so encapsulation is basically wrapping up, wrapping up data members and function. Data members and function. Okay, so this is encapsulation means. So let's think about a capsule. This is our capsule in which we have our data members and we have our data function. Okay, so this is what is encapsulation means. Encapsulation means. Okay, so for this we have one example. Let's talk about this example. Uh, Let me open this. Yeah, encapsulation. Yeah, let's see what encapsulation means. So here we have one function. We have a class name is student. We have a private name and age. So for encapsulation, basically we have data heading. So we use access modifier to implement encapsulation. We have private members. We have protected members. Okay, basically access modifier we can say. So we use this to access basically to implement encapsulation. Okay, so this is how an encapsulation works. We use a private access modifier to accessing the name and age of the student class. Okay, so this is for accessing private members. We use getter and setter function. So same as it is used here. Okay, so this is how encapsulation works. Simple. It's just we have information hiding and data hiding in this part. So why we use encapsulation in this? So the question arises why we use. So the point is data hiding, it increase data hiding, it increase security. Security. Okay. It will increase my security of the code. Second part, if if I want, I can make class read only. So what does it means? If I want my class, suppose I have a member function integer age. Okay, if I don't want to change this integer, so I cannot access my uh, integer age inside my main function without setting up a function which is set age. Okay, so if I delete, if I comment this function, let's suppose, so I am not able to set age anymore without using any setting age value. So this is what we call read only type. So why? So yeah, what we call if we want, we can make class read only. Okay, This is second. First is data hashing. Second is we can made our class read only. Code reusability will increase automatically. Let me do this correctly. Now we have encapsulation, basically encapsulation basically used in unit testing. Unit testing. Okay. Now let's talk about abstraction. So let's talk about abstraction. Okay. So yeah. So in abstraction, we usually implementation is used to hide implementation. Okay. Implementation hiding. Okay. Implementation hiding. So what are the advantage? What are the advantages? So only you can make changes to your data or function. Okay. Only you can make changes to your data or function. Data or function. Okay. Secondly, it make application secure. It make application secure. Okay. It make application secure. So let's see one example. What is abstraction means? So this is the code of encapsulation. Let's see. Let's uncomment this part. So yeah, if I want to check, I want to run some checks on a student. Okay, I have a student one here. So if I want to validate this student, so what does it do? It will verify name, it will verify address, and this is a boolean check. So if one of the value is wrong, if the value one of the wrong, the whole validation fails. Okay, when value is wrong. So as a user, I don't know. So what a user see, let me. So I just see this part. Why I'm using. Let's suppose I comment this. Yeah, I only see I am creating a student. I setting the student name. I setting the student name and age. Okay. When I ask for validation, I don't know what validation does. It's simply gonna return me true or false whether this student is present, whether this student is a legit student or not. So I don't know what validation does. So inside the validation is basically performing some checks. Okay. And this is how abstraction is being implemented. So abstraction, what we can say is generally, if I want to fly a rocket, okay. So let me suppose here, I want to fly rocket. Okay, there is a class, there is a class fly rocket. Okay, inside that we have a function fly. Okay, so I don't know what this function do, what the inside the code is doing here. Okay, simply I pass my parameters, or if I have some, so I simply use this fly function to fly my rocket. I don't know what this function is doing, what the code is inside that, how it is implemented, how it is executed. I simply want to fly my rocket, so this is how what an abstraction means. Okay, it's simple. So let's move on. uh yeah, so let's move on to our next topic. Our next topic is inheritance. Okay, so what inheritance means? So let's me write this. Inheritance. Okay, so what inheritance means? Inheritance means parent and child relationship, parent and child relationship. Okay, just check this value. Okay, parent and child relationship. Okay, suppose we have a class what we called as human. Let's make a class human. Inside human, we have some height, we have some weight. Okay, we have some age. Suppose I want to make another class of man and woman. Okay, I want to keep this all the property same as for man as for woman also. So what basically I have to redefine this height, weight, age again in the classes. So what inheritance help me in, I can use human as a parent class. So whatever member inside this parent class is what this member inside the parent class is accessible in both men and woman. So we does not have to define again inside the man and woman. Okay, so this is how inheritance works. So what is the syntax of this? Let's see. Let me undo this. Yeah, so let's see what are the syntax of inheritance. Yeah, so let's see. So first of all, we have a class. Inside that class we have, not inside, while we're defining our inheritance class, we have to put name. This is our name of child. Okay, after that colon, the mode, I will talk about the mode, and we have a name of parent class, name of parent class. Okay, so here mode, there are three type of mode: public, private, and protected. Okay, there are three type of mode to access the parent class. So in public you can access the public members, in private you access the uh, privately, and in protected as usual. Okay, so let's see one example how this inheritance work. So let me do this. Yeah, let me show one example how inheritance works. So let's copy this. So yeah, so let's encode it line by line. So first of all, I declared some variable which is publicly defined. Okay, inside that we have used getting and setting values, setting function for that class. Okay, so now let's talk about the main part. Yeah, here here we are inheriting the human as our parent. We are making child as a man. This is our child, and this is our mode in which we are inheriting. This is our mode. This is a public. Suppose I have a string. Inside that I have a color name string. Okay, I am calling a function sleep. Male is sleeping. So what this gonna do? Let me remove the, yeah. So let's see how this gonna work. So I define male. Male is my child class. Okay, middle is my child class and created an object of the child class. So now you can see I am accessing age, get age. Okay, so now in as you can see there is no age inside my child, no age, no weight. Okay, no age, no weight, as you can see. So but it is setting age in object 1, is getting age object 1. Again it's accessing its own member, sleep which is defined in the class, weight, get weight. So let's run this code. Yeah, it's initially we don't align any age, don't don't assign any age, so it will get me 0. Weight, again it's 0. Male function is sleeping, it's again we set the age 65. Okay, so we see here age is not defined, age is not defined, weight is not defined, but we are accessing. So this is called inheritance. Okay, we don't use to define again and again for the same variable. Same, suppose here let me define one more class. So suppose here I want to define, let me delete this. Suppose here I have to define, let me, yeah, suppose I have to define a class woman. Copy class, here it is woman. So for woman also, I don't have to define again the age, weight parameter. It is already defined in my parent class, age, weight, height. So we can access the age, weight, height inside this class. Okay, so this is simple. Now let's see example. That what are the types of inheritance? Okay, so there are multiple types of inheritance type. Let me change this. Yeah, types of inheritance. First is single inheritance, single. Second is multi-level, multi-level. Second is multiple. Fourth is hybrid. Third one is hierarchical. Okay, so single level inheritance, suppose we have a class A and class B is inheriting. This is called single level inheritance. Okay, so this is called single level inheritance. Let me rewrite this. What A is inheriting B. Okay, in multi-level we have similar to A inheriting B, B is inheriting C. So this is called multi-level inheritance. Let me show one example quickly. Uh, yeah, it is single level inheritance. As you can see here, my animal is inheriting in dog. Okay, so animal is inheriting dog. It is called single inheritance. In multi-level inheritance, animal is created dog. Dog is inheriting animals. Okay, and pug is inheriting dog. So here, what does we see? My animal. Let me. Yeah, my animal. What? It is not running correctly. Just a minute. Let me reload this. Yeah, it is fine. So let me again rewrite this. Where is I constructor, shallow copy, deep copy. Here it is static member, inheritance. Yeah, here I come single level inheritance, multi-level inheritance. So yeah, so it's little bit buggy. Let me do in. So basically, A is our public class, uh, basically animal class, animal. So B is inheriting animal. So B is dog, inheriting animal, and C is basically what we call pug, which is inheriting dog. Okay. So the function of, let's suppose the function is function we called 1, function we called 2. So both the function 1 and function 2 is inherited in pug. Okay. Both the function and function 2 is inherited in pug. Okay. This is called multi-level. Let's talk about multiple inheritance. Multiple inheritance is simple. We have a class A, we have a class B, and class C. So both in class C, both A and B both are inherited. Okay, so this is called multiple level inheritance. Let's see in the code also. Uh, we have hybrid, we have multi-level. We don't have any, I think, yeah. So basically it's same as we are inheriting A and B both inside the inside the class C. So what this is gonna look like? It's look like similar to like we have a class. Let me write a code, simple code. So for this, let me write it here. Yeah, we have a class, we have a hybrid, we are accessing public animal publicly. This is the access modifier, basically mode in which we are inheriting animal. We have another public, we have human. Okay, so this is how what we gonna say multi-level in multiple inheritance work. Okay, so let's talk about hierarchical. Okay, so let's talk about hybrid is also the same. In hybrid basically we have a mixture of one of these. So let's suppose we have A, we have B, we have C. So this is our hierarchical structure. Okay, hierarchical structure. Plus in class C we have a D class which is inheriting. Okay, so this is called what we call multiple level, multi-level, multi-level inheritance. Okay, so this is hybrid in which we have a one or two combination of these. In hierarchical we have simple a tree like structure. A, B is inheriting, C is inheriting. Okay, after that we have some called what we call D. Let me have some space. Let me rub this. Yeah, we have class D, we have class E, we have class F. So this is called hierarchical along with C. Yeah, this is same F, G, H, I. This is how hierarchical structure looks like. So this is all about inheritance. So because this is inheritance, we are inheriting some of the functions. So suppose we have a function. Let's suppose what we can say, we have a class A, we have a class A having function. Okay, we have a class C having function. Let's suppose function. Okay, so this is C. Or now here it is a class B which is inheriting both this function of similar name function. Let me write it as a function. So as you can see, we are inheriting both A and C inside class B having the same function. So whenever we create an object of this class and we call function, so which function does it call, whether it is A or whether it is C? So this is known as inheritance ambiguity. So this concept is known as inheritance ambiguity. Let me write it here. Yeah, let me write it here. What this concept called is inheritance, inheritance ambiguity. Okay, this is called inheritance ambiguity. So how to solve this problem? So we use here what we called a scope resolution operator. To solve this problem, we have a scope resolution operator. So what does it look like whenever we created an object of a function? So this is the what we can say wrong implementation. Whenever we have to call the function which basically present in two or more classes, we use scope resolution operator. So how this gonna we name as object, we put a dot, we have a for which class we have to call this function, we use scope resolution operator, we use function. Okay, so this is how we code. So let's see an example. So this is hierarchical infrastructure. Yeah, this is inheritance ambiguity. So let's copy this and run this code. So yeah, so let me, it's working. Yeah, it's working. What is this? So let's delete this. So we have a class A, we have a class A, we have a class B, we have a class B, and we have a class C. We have a class C. So basically A, B, we have two classes, and class C is inheriting both A and C. So the function name here is same. So let's try to run this code. Uh, let me, yeah, here it is. If I run this call, let's suppose come on this part. If I run this call, what will it gonna happen? Let's see. Yeah, it will requesting for the function is ambiguous, as you can see. So let me comment this part and run this function again. Yeah, so let's run this function. Yeah, I am A, I am B. Okay, so this is what we called an inheritance ambiguity. Okay, so we use here scope resolution operator along with the class. So which function has to call from which class? Okay, we have to use. So let's talk about another concept which we call polymorphism. Okay, so let's talk about polymorphism. So let's talk about polymorphism. So what does it means? First of all, poly means many. Poly means many, or morph, M-O-R, morph means form. Okay, morph means form. So many form. So basically we have a what we call a function acting differently under different condition, under different condition. Okay, this is the meaning of polymorphism, function acting differently under different condition. Okay, so polymorphism is basically of two type. We can say compile time we can say compile time and runtime. Runtime. Uh, what does compile time means? Compile times when it's usually when the code is compiling, and runtime the when the code is running at the running stage. Okay, compile time and runtime polymorphism. These are the two types of polymorphism. Let's firstly talk about compile time polymorphism. So let's talk about compile time. Okay. So what is compile time polymorphism? So in compile time polymorphism, we also say it is a static polymorphism. Static polymorphism. Okay, it is also known as static polymorphism. In compile time morphism, we have a two what we call properties or functions. We have a function overloading. We have a function overloading, and we have a function overriding. Function over not overriding overloading. We have two types, function overloading and we have operator overloading. Let me set as operator. There are two types of basically what we can say members of the compile time polymorphism, function overloading and operator overloading. So what does it means function overloading? So let's see an example alongside it. So what does function overloading means? Function overloading. So let me write a simple code. We have a void say hello. Okay, say hello. And we have a same function void say hello along with some string name parameter string name. Okay, and we have also a integer say hello return type say hello. Okay, it is does not have any parameter. So what is overloading means? Overloading means changing the signature of the, this is called the signature. uh, Signature, this is called the signature. This is the main part in function overloading. So changing the return type is not called as overloading. This is not overloading, and this is called overloading. Simple. Okay, changing the signature of the function. Okay, so let's see an example. This is operator overloading, this is function overloading. Okay, so yeah, this is function overloading. Here we can see we have a void say hello, we have a int say hello, in which we have changed the signature, which is string name. We have changed the argument, which is string name. Okay, so let's try to run this code. This is called compile time polymorphism. This concept is under the compile time polymorphism. Hello, we have created a string name Aman. We have passes, we have created an object. Okay, so this is how it's work. Simple. Now we will talk about operator overloading. So let's see here. we have operator overloading. So in this we usually uh, suppose we have a plus sign, so we usually do to basically subtract to integer. Okay, subtract to integer. Okay, this is the syntax, what we call syntax. Let me, yeah, syntax of it is basically, let me write in green pen. Return type, return type, and we have a here, it is called operator, which we have to overload. We have a symbol here, plus, minus, into brackets, we have symbol, and after that we have a some input parameters. We have input parameter. Okay, so this is the syntax of the, it looks like difficult but it's not. Let's see one example. So let me copy one example, function overloading. Yeah. So yeah, as you can see, we have a return type. We have a return type. After that, we have a operator keyword. After that, we have a sign. We are passing an object. Okay. Suppose we have to basically subtract two values using a plus. Okay. So let's see what is doing here. So we created a two object of same class, object 1, object 2. We described object 1 variable, object 2 variable. We use add. Okay, see here, we use add operator, and what this gonna return me? Let's run this code. So this is gonna return me subtraction of two values, 8 minus 6, which is 2. Okay, we are using add but it is subtracting me. Okay, so this is how function operator overloading works. So now let's talk about runtime polymorphism. So yeah, second one is our runtime polymorphism. Runtime polymorphism. Okay, so it is also known as dynamic polymorphism. Okay, so in which we have uh, what we call a property or a function, which we call method overriding, not overloading, it's overriding. So what does it means? So basically, suppose we are describing a function. Let's talk about we have a class animal. Okay, inside class we have a public access modifier. In public we have a called a function called void speak. Okay, this is animal. Okay, suppose I have to make a inheritance class. Let's suppose a dog which inheriting my animal, publicly public, in which my in dog class I have a function name as same as void speak. Okay, so here it's do something, here it's do something which is basically different from, let's suppose how handshake, handshake. Okay, let's suppose we have, in this will print when we call speak function inside animal, it will handshake, and when we called a dog class inside word, it will, it should be printing me out bark, barking. Okay, so we are describing the same function inside both of the class which dog is inheriting from animal. Okay, so this is when we call function, it's gonna call me handshake, okay, every time. But for this thing to work, we used to call which we called a virtual keyword. So let's talk about how to solve this problem. So we have a virtual keyword. For this we have a, let me write in green, we have a virtual keyword. Okay, we have a virtual keyword to basically redefine my function, redefine my class function, which is basically a parent class. Class function, class function, which is basically a parent class. Parent class. Okay. So let's see one example. Let's me delete this, move to this, and function overloading. We have seen function overriding. Let's see this. So yeah, suppose we have a base class. Let me write it. This is our base class. This is our type class. Mode of accessing is public, which we are in. Our base class is parent. Let's come to let's class say base class is my parent. Okay, is my parent. Okay, and derived class is my child class. Derived class is my child class. Okay, so let's see. Yeah, so let's talk about how this gonna work. So one function we are defining with without virtual keyword, one function we are defining with virtual keyword. So again, this is void display, void show. Okay, so let me roll this. Yeah, this is basically a custom, okay, argument passing. Okay, so this not gonna work. So basically we create a pointer which will point our base object and derived object. Okay, base class pointer. So first of all, we point to our base object. Okay, so when we print, this will gonna print me base, this will gonna print me base. Okay, when we point our derived pointer, derived object basically of that derived class. Okay, so this when we call our display function, it will gonna call which one, base display all, basically the function which is defining base class. Okay, and show function which is type, because we are using here to show, we are using here virtual keyword. Let me delete this for more confusion it will happen. So we are defining here my show to a using a virtual keyword, basically redefining the function show. Okay, so let's see. So as we can see here, which I don't define using a virtual keyword, it gonna call me base class of that function. Okay, so here I am calling, let's see, I am in a derived class, but I am calling function which is from base class. Okay, as you can see here. Okay, I am calling display which is currently in my derived class. Okay, it is present in the derived class. Here you can see it is present in derived class. Okay, yeah. So because I don't use any virtual keyword in my base class, here I don't use any virtual keyword. Let me mention it. Here I don't use any virtual keyword. So that's why this gonna happen. This thing gonna happen as the basically how the basic things are working in C++. Okay. So this is how the virtual keywords comes into an action. Okay. So yeah, here we have done with the four basic pillars of the OOPS. Okay, so what we gonna learn? Let's again we will talk about first thing we will talk about the size of the empty class. Empty class basically it is the recap of the version. Recap. Okay, so we talk about size of the empty class which is 1. Okay, now we will talk and after that we will talk about access modifier. Access modifier which is of three type: public, private and protected. Okay, after that we will talk about size, how the size is defined in the class using padding and padding and grading alignment. Greedy alignment. Okay, after that we will talk some of about what do we say, mm, constructor. Yeah, 9. Static and dynamic allocation. Static and dynamic allocation. So how we can define? We are using new keyword to define it dynamically. Okay. After that, we will talk about some constructor, how default works, constructor works, and how we can create our custom constructor uh, along with different signatures inside that. After that, we will talk about some what we call shallow and deep copy. Shallow and deep copy. Shallow copy is basically sharing the same memory along its copy, and deep copy it's created a new separate memory for that copy. Okay, for this is called shallow copy. After that, we will talk about some what we call static keyword. Static keyword. Static keyword. Okay, static keyword. Basically, we can define a member inside the class, but we can use without creating any object. Okay, so this is what a static keyword use for. After that we will see four pillars, four pillars of OOP. First one is encapsulation. Encapsulation basically implement using public access modifier. Okay, let me redact it. Access modifier. uh, After that we will see about we have an abstraction. In abstraction we usually see how the function is implemented without basically knowing the how the things gonna work inside that function. We specially use that function. One of the example of abstraction is we can say power function xy in C++. Let me do some yeah, power function. Okay, in C++, in C++, we use basically we don't know the implementation how power function is implemented, but it's give me the final output. So this is called abstraction. After that we will see inheritance. Inheritance, how we can inherit a class, basically parents and child relationship. So this is all about it. After that, in inheritance we talk about ambiguity of inheritance. This is basically when what we can say two function defining the same defined in different classes, but the function name is same. So how we can call that different function in different classes. Okay, after that we see polymorphism. Polymorphism We have two type of polymorphism. We have compile time and we have runtime polymorphism. Okay, we have compile time polymorphism, we have runtime polymorphism. And compile time polymorphism, we have two types. We have function overloading and we have operator overloading. Okay, in runtime we have one type, which we call function overriding. Overriding, RIDING. Okay, function overriding, simple. So this is all about today's OOPS lecture. So thank you.